Hello all, good morning. Today we are going to discuss about domain name system, DNS. So what is DNS? So DNS is a domain name service or domain name system. What actually do this in the real time? So I can say this, without the DNS, there is no internet. So there is no internet. Without the DNS, there is no internet. So how can I say this? Let me explain. See, if you browse anything, google.com, okay, or yahoo.com. So you're browsing the websites, you're visiting the websites in a day. Lot of websites uh, we usually visit the websites in a day-to-day basis. So this DNS actually provides results of names to IP address and resolution of IP address to host name. So host name to IP address to host name. So DNS is what exactly doing is host name to IP address to host name. Vice versa, this DNS will convert the request. Whenever the request comes with IP address, it converts to host name. Whenever the request comes with a host name, it converts IP address. Why we need to convert IP to host to IP in the in the network? Domain name system. Why the DNS need to uh, conversion do the conversion of host name to IP to host name. Host name conversion, host name to IP address and IP to host name. Why the DNS need to do this? Okay, means see network. So network works on IP address, right? Without the IP address, the network won't run. So network is running on the IP address. So if one computer communicate to another computer based on the IP address, without the IP address, both computers. So there is no communication between computers. This we discussed in the demo class. After demo, we discussed this first or second classes. So there is a communication. This is sys1. Sys2. So this two computer communicating on IP address, right? Without the IP address, these two cannot communicate. So IP, right? So without the mobile number, can we communicate? Can we call to anyone? No, right? We cannot call to anyone without the mobile number. Likewise, if both systems want to communicate each other, need a IP address. Without the IP address, they cannot communicate. Okay. So DNS, what DNS do here? See, on IP address, we are able to communicate each from sys1 to sys2, sys2 to sys1. Okay. But for example, sys1, the host name is sys1. Here, host name is sys2. Computer understand, even users cannot remember this IP address. In human brain, compared to text, numbers we won't remember much. Don't know, but our human brain forms more familiar with the text when compared to numbers. we remember names. So you can still remember your 10th classmates' names, but you cannot remember their hall ticket number. You cannot remember their roll number. Even you cannot remember your roll number, right? When we cannot remember phone numbers, right? Even maybe one or two, oh, like father, mother, sisters. Maybe we remember few numbers, but we cannot remember all the numbers. So, but here network needs IP address. Network needs IP address, but our human brain cannot remember the IP addresses, right? We cannot remember the IP addresses. So what should we do then? So then DNS helps to us. So what DNS do? DNS do, if you remember host name, because I remember sys2. If I ping sys2, this DNS what resolves host name. I'm calling sys2. I'm calling a host name. So it converts IP address because network needs IP address. Network needs IP address. So if I call sys2 as a system2 instead of IP address, if I call sys2 with the host name, the DNS converts the host name to IP address because network needs IP address, not host name. Networks wants IP address. So if I call from sys1 to sys2 with a host name, the DNS converts host name to IP address because network needs IP address. And for example, if I call sys1 with IP address, the DNS converts IP to host name. So wherever needs host name or IP address, DNS converts that. So coming to internet. So as I said, without the DNS, there is no internet. Exactly, without the DNS, there is no internet means there is no much internet usage. I mean, there is no much internet usage. Without the DNS also, internet works, but we cannot see this massive usage across the world. So massive usage means, see, even illiterates also can browse the internet. They cannot remember the IP address. Even we cannot remember the IP address. Can we remember the Google IP address? Can we? No, right? We cannot remember. We know google.com, we know yahoo.com, we know msn.com, we know microsoft.com. So we know the website address, URL, but we cannot remember their IP address. So if we remember the IP address, then only we'll get the internet. In that case, if that is the case, the internet usage will go down because whoever remember the IP address, those only can get the internet. I mean websites, right? So others cannot get the websites, they cannot browse the websites who doesn't remember the IP address. So that is the reason I said without the DNS, there is no internet. Means the uses of internet is drastically down. Only few people can use the internet because those who have remember IP address of the Google, right? So I will show you this. Ping google.com. So this is the IP address of Google. How many members can remember this? How many members can remember this? We cannot remember, right? See, I'm getting Google. With the IP address also, I'm getting Google. There is no internet is, I mean, DNS is not required, but still we can communicate with IP address, but DNS. If the google.com, see, we are able to see the google.com. So instead of this one, we are able to see without the DNS, we can see the only IP address here. See why we are able to see the google.com? Because of DNS. Without the DNS, there is no internet, means there is many factors. Many factors. Okay. So coming to how the DNS works in the real time, how the DNS works in the backend. Let's, okay, quickly. Okay. So this is, let us know quickly. So this is the my computer, PC, my PC. Okay, personal computer or system or client, whatever we can call it. Okay. Okay. So in the PC, www.google.com. So I browse this website. So what this request will go to my local DNS, sorry, my local gateway. Means local gateway means router, your Wi-Fi router. Okay, Wi-Fi router or router. If you are in home, it is a Wi-Fi router. If you are in an office, it's a router. Let's say router, not Wi-Fi router, router. So your request goes to your router because www.google.com is not in our mission. It's somewhere else. So request will go to router. So router, one moment. So router, from the router, interesting. One moment, guys. From the router, it will go to, sorry, it will go to internet. Internet. It will go to internet. Or we can call public network, WAN, what WAN or a public network, or internet. In a layman language, we call internet. Internet. WAN or, okay. From the internet, so where it go? So the request google.com, when I browse google.com in my PC, it will go to router. So from router to, it will go to public network. Okay. In the public network, this is called routing. Routing will happen here. This is dynamic routing. In CCNA, you will know this routing, static routing and dynamic routing. Here, dynamic routing will happen. Dynamic routing is means, what is dynamic routing? Dynamic routing is finding the best path to reach the destination. Finding the best path to reach the destination. What is the destination? www.google.com. Where the www.google.com is there? To find the www.google.com. So here hopping here, hop will happen. So routing. So this is public DNS, all DNS. Okay. So from public DNS here you will get the Google DNS information. Here it will route to where the Google is. Where the Google DNS is, here you will see the Google DNS. This is Google DNS. Finally, it reached Google DNS. Okay. So this is a website actually. www.google.com is a website. Okay. So before going to the web server, it reaches Google DNS. It reaches Google DNS. In the Google DNS, Google DNS know where the google.com website means web server. So this is web server, Google web server. So this is Google web server where the google.com is there, where the google.com, here the website. This is the website. Google.com website is hosted here in this machine. So what Google DNS, because how the Google DNS know about the web server? Because in Google DNS having the information of this web server, having the information of this web server. So this web server information in Google DNS. So what Google DNS respond to the request with the IP address of Google web server. So let's say this is the Google web server IP address. This is the IP address of Google web server. So here Google DNS respond to our request. Please contact this IP. Please contact this IP. So this public DNS respond to here with IP. Okay. So response is IP. Again, from here to here to here, IP. So IP is coming. Our request is www.google.com. So we browse in the Chrome or somewhere else. I mean, Edge or some browser. So Google DNS responded to us with the IP address. What is this IP address? Google web server IP address. So taking this IP address, contacting to Google, Google web server with this IP address. Now, once we contact Google web server, so Google web server load the URL into our browser, See, this google.com will load in our browser. This is how DNS works in the real time. But this transaction happened in a seconds, milliseconds, microseconds. But we never experience this process. We are only once we google.com, say it is loading quickly. So we never experience this. This is a backend process. How the websites, not only Google, any website is loading into your system's browser, because this is a backend process. How the request is routing to DNS, from the DNS to our system, and our system to web browser. Are you clear, guys?
Yes, sir.
Okay. Now, so DNS is not a particular service for Windows or a Linux. It's not a platform dependent. it is a platform independent. It is a platform independent. So you can configure DNS in a Linux servers, Windows servers, Unix servers, so on. So it's a platform independent. So DNS is a service where we can make our network smooth or harmony. So if our network runs in a harmony, we use DNS. So in DNS, we can our network will run very smoothly. So coming to in DNS, see DNS runs in these operating systems and many operating systems. Not only I'm just quoted here few like Windows, Linux, Unix, NetWare, something. Okay. So here two types of DNS servers. Authoritative DNS server, non-authoritative DNS servers. Authoritative DNS servers. So return the request IP address, return an authoritative. This is called authoritative DNS. Non-authoritative DNS checks its cache, use forwarders, use route hints. This is non-authoritative. Okay, authoritative and non-authoritative. So these both combination of DNS is called a DNS, a proper full DNS. So in the DNS, we see two types of DNS, authoritative and non-authoritative DNS servers. So DNS, fully qualified domain name, FQDN. What is this FQDN? FQDN means host name plus domain name is called a FQDN. Host name plus server, host name plus domain name is called FQDN, fully qualified domain name. Okay. So if you see DNS names, if you see host names, winadc.arn.com. So that is fully qualified domain name. That is fully qualified domain name. For example, here, host name plus DNS name is equal to FQDN. What is the host name? sys1 is the host name. Domain name, ms.com. So sys1.ms.com. So for example, so this is called a FQDN. So if this is arn.com. So what will happen? Fully qualified domain name, sys1.arn.com. Okay. So examples. What is a fully qualified domain name? Means host name plus DNS domain name. That is called fully qualified domain name. So in DNS, there are two types of zones: forward lookup zone, reverse lookup zone. What forward lookup zone do and what reverse lookup zone do? Forward lookup zone used to resolve the host name to IP address. This zone do only host name to IP address. It maintains host to IP address mapping information. Reverse lookup zone do used for resolving IP address to host name. So if any request comes with IP address, it converts host name. If any request comes with a host name, it converts IP address. Okay, so it maintains IP address to host mapping information. So both zones are maintaining information about IP address and host names. Okay, so in DNS by default there are records, set of records by default. When you install the DNS, you will see this records. What is the records? Let's have a glance. SOA record, the first record of any zone file. This is the we call first record. What this record do exactly? This record having a administrative information. This record contains administrative information. This record contains administrative information. So all the administrative DNS information in this record. Next, what is NS record? This is name server. We call name server. Identify the DNS server for each zone. Identify the DNS for each zone. So this NS stands for name server. So because of this name servers, we are able to find the DNS location. We can able to find the DNS location. We're able to find the DNS location. So without the name server, name servers are is a path. Name servers is servers where we can route the request to the DNS. Okay. So that is called name servers. Here I given the information. And name servers record indicates which DNS server is authoritative for that domain. Okay. And basically, NS records tells the internet where to go and find the domain IP address. So because of name servers, requests easily find the DNS server. Okay, because of name servers. Next, host record resolves the host name to IP address. This host record resolves host name to IP address. So, and alias record. What this alias record? Resolves an alias name to host name. Alias is nothing but a nickname. Nickname, how we have a nicknames like, and records also having alias names. Alias names means same, it resolves to the original name. So nickname, when we call someone with a nickname and original name, they will respond, right? So likewise here, alias name, if you call with alias name also, we can call host name. We can call host name with alias name also. Okay, a canonical name. This is we call a canonical. A canonical means CNAME record, a type of DNS record that maps an alias names to the true canonical domain name. We called CNAME. Alias names we call CNAMEs. Canonical name. CNAME records are typically used to map subdomains such as www or mail to the domain hosting subdomain content. So this canonical name map to original host names. Okay, and pointer record. This pointer record contains resolves an IP address to host name. Resolves IP address to host name. So like a host record. So it having information about IP address and host name. Here also information about host name and IP address. So both are kind of reverse, vice versa. The host record and PTR records works vice versa. Here host to IP, here IP to host. Next, MX record. MS record used by the mail server. MX record used for mail servers. So without this record, mail servers will not work. So we are able to send mails because of this record. If DNS doesn't have this record, we cannot send emails. We cannot send emails. Mail exchange. MX record directs emails to all mail servers. The MX record indicates how the email messages should be routed in accordance with a simple mail transfer protocol, SMTP. Like, so MX record is very much important in the DNS. Otherwise, our mails will not go and come. Okay. Next, SRV record. This is service record. So resolves the names of the server, provide the services. So this is a SRV record, service record we call. So resolve the names of servers providing services. For example, if you have a services like WW service, World Wide Web service. So all the services information in this record. See, SRV record specified a host and port for a specific services. We usually host many services in the real time. So For these services, we host the services in the DNS, like www is the best example, okay, and VoIP services and instant messages, okay, so on. Even if the Zoom, this is works on VoIP, this is VoIP, voice over IP. So our Zoom service is working in a voice over IP. This information in Zoom's DNS. Otherwise, we cannot communicate. Okay. Most records only specify a server and IP address, but service record includes port number and that IP address as well. In the service record, IP address and port numbers. The service record having port numbers and IP address of the particular service. Okay. So, and one more is, and coming to, if you observe, notepad, www.google.com. So this is website. We call URL, right? One moment. DNS and just not here. One moment. There is a picture. I would like to show that picture. Yeah. See, close it. Yeah. If you take this DNS tree, I would like to explain this DNS tree. See this dot. This is called unroot. This we called root. This is we can call also unnamed root. Unnamed root. And next .com. What the com? Com is top level domain. Top level domain. Okay. And next, this is Google. This is second level domain. Second level domain. Google. And www is a host name. Or some, for example, if drive, I will show you. I'm opening Google Drive. See, drive.google.com. See, if you observe drive.google.com. So this drive is also second level domain. Drive.google.com. This is also second level domain. And also we call this, we can call subdomain. This is only drive is subdomain. Subdomain. This is subdomain. Okay, second level domain and subdomain and host name. This is how DNS tree is. See, root, unnamed root, and this is top level domain .org, .net, .com, .ca, .us, .uk, and .in. all top level domains, and these are second level domains, and this is host computer. This is host computer. So why we need this? Are is really needed to remember this? Yes. You do you think how exactly when we browse google.com, how exactly it is going to google.com? Okay, so what is here? I said dynamic routing. Here dynamic routing to find the public DNS. So it will go to public DNS. In the public DNS, how the request is going to Google DNS exactly, right? Anyway, we are giving URL, sir. That is the reason it's going directly. Of course, yes, true. But in billions of trillions of websites we have. Trillions of websites. I believe we have trillions of websites. So in trillions of websites, how fast we can find the google.com? It takes a lot of time usually, but it is going to particular DNS, requested DNS, okay, very fast. It is going from public DNS to Google DNS very fast. What is the mechanism they are using? Means, see, first of all, the request first will go to root. Root means under the unnamed root, we can see there are many top level domain servers like .com, .in, .us, .uk, .org, .ca, Canada. Okay, there are many top level domain servers. So in the URL, first it reads dot. So it will go to root server. From the root server, after root, it reads .com. So directly it will go to .com. So under .com, what are the second level domains? Even in second level domains also trillions. So based on the google.com, so it will go to directly .com, will not check other top level domains. Other top level domains, right? So after, if it in our URL there is a com, so it will go to directly com top level servers. Once go to .com top level domain, searches google.com. So it is easy, right? In top level domain, we can easily find the google.com because of name. So if the request is going to every server, top level domain server, it will take time. But in our URL, .com is there. In the top level server, .com, top level domain server, it will directly go to .com. In the .com, it search Google. Search Google. In the Google, we have a record www. www means where the web server IP address here. Web server IP. So that is the reason the public DNS quickly find the Google DNS because of this tree. Okay, clear, guys? That's all about theory. Now we are jumping into lab. So log into DNS. See, we no need to install DNS because when we install Active Directory services, by default DNS will install. By default DNS will install. So here, if you see DNS, because the DNS is prerequisites to install Active Directory. So when we install Active Directory, definitely DNS will install. So we no need to install DNS if in the servers. So the process will be the same to install DNS. Say add roles and features. No, sorry. Click next. Click next. So you need to enable DNS. So it is already installed, so not required. Now let's configure. Go to DNS, expand, 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 forward lookup zone, reverse lookup zone. Okay. So now I would like to create a zone. Here you can create n number of zones. N number of zones. Now I'm going to create a zone. Okay. Right click on it. New zone. See, already there is a zone called arn.com. So I'm creating one more zone. One more zone. Click next. This is primary zone. Primary zone. Click next. Click next. To all DNS servers running on the domain controller in this domain. Click next. Zone name. Here you need to give zone name. So I'm giving Yahoo. Yahoo.com. Yahoo.com. Click next. Click next. Here you need to one moment. Click next. Yeah. Here you need to allow both non-secure and secure dynamic updates. So why we need to select this? If, for example, because of DHCP server, computers, client machines, IP address keep on changing. So client machines usually update their records in the DNS. So we need to allow both secure and dynamic updates, non-secure and dynamic updates. Click next. One moment. Yeah, we need to uncheck this. Sorry, we need to uncheck this. So this is active directory integrated zone. I don't need active directory integrated zone. I need a primary zone. So what is primary zone, secondary zone? We'll discuss. See, simply primary zone and we'll discuss tomorrow. That is tomorrow topic. So let me create a standard primary zone. Okay, primary. Click next. See, create a new file with this file name. Click next. Allow both secure and non-secure and dynamic updates. Secure dynamic. Okay. Click finish. Click finish. See, yahoo.com is zone is created. Okay. And create a host file. Create a host file. This is host file. So you need to give host file. So what is the host? Because this is a host computer. Win AD. Give win -AD. You don't need to give Windows is a not a case sensitive operating system. You can give a smalls also, uppercase, lowercase, and lowercase, uppercase also. Okay, no issue. Not like a Linux. This is not a case sensitive operating system. You can give uppercase, lowercase, and a combination of lowercase and uppercase also. Okay, and IP address. What is the IP address? 10. 192.168.223.10. This is the host computer. So we need to add the host name. Okay. Now, now create a alias record. Alias means nickname of this record. Okay. So this is alias record. www. Okay. Browse the host link the host original file. This is original file. This is original file. Okay, created alias record also. So now verify. Now verify. If you want to, you can verify it. Ping www.yahoo.com. See, I'm able to ping the yahoo.com. Okay. So likewise, we usually create zones for a particular website's URLs. Okay. Now coming to reverse lookup zone. So now I want to create a reverse lookup zone. Okay. So if I right click on it, new zone, click next, uncheck this primary zone. It's a primary zone. Click next. The IPv4 reverse lookup zone or IPv6? We are using IPv4. What is the network ID? This is network ID. 223 is our network. So given network. Because see, in our 223 network only, all our systems installed or deployed. Click next. So this is a create a new file. This is a new file we'll create. Allow both non-secure and secure dynamic updates. Finish. See, created. Here we need to create a PTR record. Here we need to create a PTR record, pointer record, PTR. Okay. So in PTR, what is the IP? 10. Okay. The host computer IP is 10. 10. Browse and link up the host name, all records. Link up this host record. See, this record. Okay. Okay. And 1 second. I will all or we can give alias host record. This is, yeah, this is host record. Select here. Okay. Okay. So host record, because we need to point host record here. Okay. Now it's done. Now you can verify here. You can verify like NS lookup and give 192.168.223.10. See, let's command prompt is best. So I'm just verifying the DNS here. NS lookup www.yahoo.com. See, this is how DNS and reverse NS lookup 192.168.223.10. See, this is how address is coming up. So it will take time to come up properly. 1 second. And you can, so similarly, from my system, I will, yeah, NS lookup google.com. See, NS lookup, what is the IP address? This is the IP address. So NS lookup is a command to check the DNS, See, so we will get this kind of name after some time. See, here we didn't get, it will come. ipconfig flash DNS. So removing the cache, sorry, ipconfig FLU flash DNS, correct. FLUSH, right, FLUSH, enter. Renew. Renew means, yeah, FLUSH. What is flush and renew? Flush means clear the cache of DNS. Clearing the cache of DNS. So to clear the flush DNS, why FLUSH DNS? Oh, right. FLUSH DNS. Yeah, now it is working. So maybe space, maybe might I given space. Okay, so flashed means just removing the cache of DNS. How we are removing the cache in the browser? So in DNS we can clear the cache. Okay, now NS lookup www.yahoo.com. Okay, it's coming. Now I will give IP address. Yes, it's coming up. It's take time. It is coming up. See, it is working. DNS timed out. DNS server. This one. So DNS request timed out. Okay, request unknown. So DNS is working. We can call DNS is working. Now coming to creating standard primary zone, creating standard reverse lookup zone, primary forward zone, primary reverse lookup zone. Next, creating secondary zone. What is secondary zone? Secondary zone is nothing but a backup zone of primary zone. Backup of primary zone. So if you want to create a backup zone of this primary zone of forward, primary zone of reverse, for to backup, for example, unfortunately these got deleted, then we can create a secondary zone. Let's create a secondary zone for primary zones. Okay. So go to other system. See, in this system, we will create a backup zones of primary DNS zones. Go to tools, DNS, expand this. See here, right click on it, click new, click next, secondary zone. See, create a copy of a zone that exists on another server. This option helps balance the process of load of primary server and provides the fault tolerance. Yes, here, as we discussed for DHCP, there is a secondary server for load balancing to share the load and fault tolerance. If the zone is got deleted here, and we will have a zone here. So for sharing the load and for fault tolerance, high availability, we create a backup zone that is called secondary zone. Okay, click next. What is a zone name? So we need to select secondary zone here, click next. And what is the name? Name we have to give. Name yahoo.com. I'm creating a backup of Yahoo zone. Here Yahoo zone is there. So I'm creating a backup of this zone, Yahoo. Click next. Here you need to give the primary zone IP address. What is the primary zone IP address here? This is the primary zone IP address. So you need to give IP address here. 192, click here. 192.168.223.10. Why this is coming up? Okay. This, let me delete this. This is IPv4 version. Okay. 1 moment. Let me close this and reopen because it is not detecting. That's it. And make sure, let me check the IP address of this both. Okay. 11, yeah, 10, perfect. Let me open DNS. Right click on it, new zone, click next, uncheck this, secondary, click next, yahoo.com, click next. Here you need to add IP address of 192.168.223.10. Yeah, now it is coming up. Okay. Click next. Click next. Finish. So the secondary zone here, secondary zone got created. So fine, secondary zone is created but not synced. Not synced. So we need to allow secondary zone to sync. So come to this server, expand this, right click on it, yahoo.com, go to properties. Go to properties. So here we need to allow secondary zone to sync the data which the primary zone having. Okay. Now click zone transfer. Only the following server. Click edit. Here you need to give IP address of secondary zone. What is the IP address of secondary zone? 11. System IP 190. 192.168.223.11. Okay, fine. Click OK. Click OK. Even error is fine here. Okay, apply. Just OK. Okay, now see here is nothing, right? Just refresh it. It will take little time to sync the data. Okay, so let me close here and open. Here also, see, let me refresh it. Just close it and open again. Or else you need to, if still is not synced, see, still it's not syncing, then what should we do to make it fast? Otherwise, if you give time to this, it will sync automatically. If you want to make it fast, if you want to sync it fast, then go to services and run DNS. Restart the DNS service. Restart it. Okay. Come here. Refresh. Still it is not syncing. Expand this. Yeah, now it is see. Now you're able to see the data. So if you give time, it will sync. Otherwise, if you want to make it fast, you need to restart the service. See, now able to see yahoo.com zone. So this is the secondary zone. Secondary zone. So that's all for today, guys. Any questions? Any questions? Okay. Thank you all. Thanks for joining. Have a great day. See you.
Thank you, sir.
See you tomorrow at 9 a.m. We will have a class tomorrow at 9 a.m. We will discuss your lab issues, your concerns, questions, everything tomorrow at 9 a.m. Okay.
Okay, sir.
Thank you.
Okay, sir. Thank you.